Alright all, welcome to the last week of notes for Intro to Algebra. If you haven't already, please review the description of what your final exam in this class is going to look like that I posted on Monday. And please send me any questions that you have now because I want to make sure that all those questions are out of the way before the actual final starts, because you're going to have plenty of time to work on it, but there are some expectations and it is still worth 10% of your final grade in this class. So, we still have a week left, and you'll have another week of full practice before the final, plus many days to work on the final itself. So, let's do our last lessons, but if you have questions on that, please get in touch as soon as possible. So, here we go. Here we've got our homework for today, and our objective, which is to categorize polynomials. So, again, as I would usually hope, a bunch of you would ask, what's a polynomial? Well, a polynomial is a sum of monomials, which is not that helpful of a definition yet. But thankfully, you'll notice that the next vocabulary word directly underneath this is monomial. So a monomial can be a number, variables, or the product of those two with whole number exponents. So examples of monomials would be something like a number, so 3, a variable, y, their product with whole number exponents, 2x squared, 1/2 a to the 15th. These are all monomials. You'll notice here that it's fine if the number is a fraction. It just can't be that the exponents are fractions. So now that we know what a monomial is, a polynomial is just a bunch of those added together. It's the sum. So we could have something like, let's look at number 1, a. If we've got, determine which is a polynomial. If we've got 2x squared plus 4, you'll see it's a sum. And this is like here, and 4 is like 3, it's a number. So here our first example is a polynomial. And there's several different types of polynomials. Polynomial is sort of the general term. The next question would be, is it a monomial, binomial, or trinomial? So if you remember your scientific prefixes, mono, bi, and tri just tells us a number. So you'll notice monomial is like one of these terms. If we're looking at a binomial, that means it's 2 of the terms. Trinomial is 3. And polynomial just talks about sort of the general, right? It's poly just means many, so there's more than one. So there are polynomials that are longer than 3 terms. We don't usually give them a special name. We just call them polynomials. So in this case, with number 1, part A, we have 2 terms here. We have 2x squared plus 4. Those are our 2 terms, which makes it a binomial. So let's look at the next couple, see if we can determine which are polynomials and if they're monomials, binomials, or trinomials. So B, negative 4x to the negative 2 plus 3x. So we still have 2 terms, just like A, but this is not a polynomial because you'll notice that the exponent is a negative 2. Whole numbers are positive integers, right? So because this is negative, it's not a polynomial. Things that aren't polynomials don't have special names. We just say that they aren't a polynomial. So C, we've got negative 4m squared n. Now, this is one term, so it might be a monomial, and in fact it is, because remember, monomials can also be their product. So you see how these are all multiplied together, right? Because they're all just sort of shoved together without a symbol in between. This is a monomial. It's okay if it has more than one variable, as long as they have whole exponents, right? This one has an exponent of positive 1. We just usually don't write it. And then the number can be whatever it wants to be. So this is a monomial. D, again, kind of looks like a monomial. It looks like part C, but you'll see here is that we have a decimal in our exponent, and so this is not a polynomial. And lastly, we've got number 7. This is a monomial, just like we see as one of our examples. I think, yep, I used 3 here instead of 7, but the same thing applies. All right, so there's one more piece of vocabulary that we're going to see here. All right, our last vocabulary term at the bottom of your notes is degree. We talk about polynomials having degrees, and it just tells you something about how they act and how many terms they often have. Degree is just asking you to find what is the largest exponent on any given term. So you're just looking for any term, the one with the largest exponent amount. So if I'm looking at 2, find the degree of the following polynomials. If I look at A, I'm looking for which of these terms has the most exponents. That would be this first one. And we can see here, so even though these 2 terms don't have a 3 as an exponent, we call this whole thing a degree 3 polynomial because one of the terms has it. It's enough if just one term has that high of an exponent. Now sometimes it gets a little bit more complicated because you'll notice here that we only have one term, so this has to be our term with degree. And you'll notice it's also tricky because this is clearly our term that we're working with since it's a monomial. We only have one term, but we have 2 variables. We've got a 5 and a 3 on the B. Because it's a single term, right? This is the idea, it's one term. The exponent amount on that term is all of it together because when we simplify exponents on terms that are being multiplied like this, that means that we add those exponents. So the degree here is equal to 5 plus 3, since they're on the same term, right? They're being all multiplied together. Versus A, where we have 3 separate terms. That means that we get a degree of 8. Now, you also will have ones where it looks like there's not an exponent. We saw this in number 1. This is got an exponent of 1. This doesn't have an x at all. And so that means that this is our term that we're going to use. And even though we had to write it in, that's all right. Here we have degree is equal to 1. Our last one, we got our fun little monomial 7 again. And this we can write the degree, but you'll notice that there's no exponent at all because there's no variable. And so we can say, all right, well, this is still a polynomial, but its degree is 0. There's no exponent. And this hopefully will make a little bit of sense because 7 is the same as 7 times x to the 0, because that's 7 times 1. So though we would never write this in a simplified form, right, that looks really weird, it still has an exponent of 0. All right, hopefully this new vocabulary feels pretty familiar, pretty comfortable. This is definitely a set of problems where you're not going to be showing a ton of work, but that means they should go pretty quickly. So let me know if you have any questions in the comments or on Zoom or in email. Talk to you later.